Greetings, APE students. Today we're on location at a pond right behind my house where we're gonna get some water tests done. Some of the tests that you guys read about and did the water test case studies on are things we're actually going to test on 2 bodies of water. So we've got the pond here, and then we're going to do some tests on a creek, which is obviously faster moving water than what's here. So before you do any water sampling, you should always kind of get a look at your surroundings, where you're getting your water sample from. So if there's vegetation and yards and farm fields and construction sites and animals, all that is going to kind of give you clues as to why your water quality is the way it is. So as you look around the shoreline here, you see probably, you know, anywhere from, I would say, 20 to 30 feet or more of vegetation, which is good. Lots of cattails, lots of tall grasses. On the other side of the pond, there's a gray house over there and then a tan house next to it. Right where those people are walking over on the side there, there's an inlet, so water can come from the pond across the road, under the road, and actually flow into this pond. This pond is part of a system of ponds, kind of part of the Spring Creek development, and there's 4 or 5 ponds here along with the creek itself. So there's a storm water inlet over on the other end of the pond, and then some other unique characteristics about this pond is that we actually have springs in here, and there's about 5 springs that keep water moving, and oftentimes even in the winter time it doesn't 100% freeze because of the springs. But animal life here, I guess there's one lone Canadian goose out there. This is a popular spot in late February. Lots of waterfowl make it through here. We had trumpeter swans here about a month ago, hooded mergansers, which are a type of waterfowl, lots and lots of different types of ducks. But you can see it's a pretty big pond. Also, notice there's a lot of development along this pond, so development can play a huge role in water quality. So you got houses that are basically all around the pond, plus kind of a tarred walking path here as well. So anyway, the tests that we're going to do today are dissolved oxygen, pH, temperature change, fecal coliform, BOD, nitrate, phosphates, total dissolved solids, and total suspended solids. Some of these I'll do right on the site here, and others I'm actually going to take the water sample back to the high school, and we'll do the test there. My wife already said she didn't want fecal coliform growing in her kitchen, so I guess we'll take that back to the high school. But I do want to do a dissolved oxygen test for you, so for that I'm going to go down to the edge of the pond. Okay, so first we're going to get the temperature, and to be about 15 degrees Celsius, and then we're going to grab about 25 milliliters of water. And we're going to measure, whoops, dumped out too much. Okay, now we're going to measure the dissolved oxygen. This vial has water in it from the pond, and we're going to do what's called the DO test now. DO stands for dissolved oxygen, and dissolved oxygen plays a critical role in water quality. The higher the dissolved oxygen, the better chances you'll have to support game fish like trout and walleye and sunfish and crappies. All require higher dissolved oxygen. So basically what you do is you take one of these vials that have chemical inside, and you stick it in there and you break the tip off in the bottom of the container. and you let that water and you let the contents of the vial mix for a little bit, and then you compare it to a color chart. So we've let about a minute pass, and we're going to now compare the color of our sample with what's been given to us in this kit. And you can see there's a range of colors ranging from 1 part per million, which is milligrams per liter, all the way to 12. And the higher the number, the more oxygen in the water. And as you can see, this is a little brighter. It's kind of hard to tell with the sun, but it's certainly a darker blue. I would say somewhere in the 10 to 12 range. What do you think, Lauren? Maybe 12?
Sure.
Okay, so 12 parts per million we'd record. So we got our first test done. There's the guy that's been wreaking havoc with trees around here, the beaver. He comes from the pond over on the other side of the road and comes over here and wreaks havoc with our trees. Yeah, 15, 14. So next we're going to do a pH test. So I got about 10 milliliters of the pond water in here, and it's pretty simple. Most of what is used to determine these tests are what are called the Lamont test kit, and it's kind of like our soil test where we use a lot of tablets and indicator reagents and so on. So this is real simple. You fill it up to the 10 milliliter line, you add 1 pH tablet, and you wait until the tablet's disintegrated, and you compare it to a color chart, see what the pH is. So we'll do that right now. So I let the tablet disintegrate, and it looks like we're probably right in the 7 to 8 pH range. Not perfect match for either one of them, but maybe somewhere in between 7.5 or whatever. So I'm just going to record 8 for a pH. Measures how clear the water is. It's called turbidity. And if I had something called a Secchi disc, I would go out into the water with my canoe or my kayak, and I'd drop the Secchi disc down and I'd read the water clarity that way. But you can kind of cheat with this little device. And what I did was I filled water from the pond up to the 25 milliliter mark, and then if you notice these little patterns on here, you put the base of the apparatus down on top, and you look through and you match it up with what's given on the outside. So if I put it right there and I look through, I can still see the alternating black and white triangles pretty easily. I would say either 0 JTUs or maybe somewhere between 0 JTU, 0 and 20, like maybe 10. So I'm going to go ahead and record 10 JTUs, which is actually really, really good water clarity. Next test is a test for phosphate. Phosphate is something that can really do some harm to water, bodies of water. And again, the test is pretty easy. Take a test tablet. And put it in there. And we'll cap it. And this one we got to wait 5 minutes for. So we waited 5 minutes, and it looks like there is 0 phosphate in this body of water, which is good. Now that may change a month from now or even a few weeks from now once people start putting fertilizer on their yards and farmers on their fields fertilizer, but right now I would say 0. The last test we're going to do, at least on the site, is a nitrate test. And this involves 2 tablets. One is a nitrate test tablet number 1, which is this one. Where'd it go? Let's try this. So we'll let this dissolve, and then we'll add another one, and then we'll wait 5 minutes and check the color, and then we should be done with 5 minutes for the nitrate test. And you can see that there's no color really at all. I'll try to get out of the sun. It's kind of a pale yellow. I'd maybe count that as like a trace of nitrate. I don't even know if it's 5. Maybe we count it as like 2 or 3, because 5 indicates maybe a slight pink, but we'll count it as maybe like 3 parts per million of nitrate. Site number 2 now. This is Spring Creek as it flows underneath Jefferson. So we're kind of over east of the soccer fields right now. And if you look straight north, which is where Lauren's pointing the camera right now, that's where Spring Creek would go. It keeps going about a mile or so up and then enters the golf course and flows through there, and then after it leaves the golf course it heads down towards Carlton and actually enters into Lyman Lakes, and then it enters into the Canada River. So that's where Spring Creek goes. But as you can see, the water flowing over the rocks is moving, and moving water tends to hold more oxygen. It tends to kind of stir up the, I shouldn't say holds more oxygen, produces more dissolved oxygen. So I don't know if we're going to get any higher numbers than what we got before, but we'll get a sample from there and measure the DO, and then I'll get a regular water sample from here, and I'll do all the other tests that we did earlier, but not maybe right on the site. Same temp, 15. Well, I'm back in the school now. It's pretty quiet around here, and I'm doing a couple other tests. You can see the vial on the left is Spring Creek, and the vial on the right is the pond. So what I'm testing for here, and you can tell by that card, it says coliform bacteria. This is fecal coliform bacteria. So this is bacteria that comes from waste of organisms and so on. And you have to let this sit for a couple of days, so we won't be able to see the results of this until Thursday. But as you can see, if it is kind of a yellowy color, that's a positive test for coliform bacteria, and if it remains kind of the red that it is, that's negative. So we'll have to wait a couple of days for the results of that one. Okay, the last 2 tests are for measuring total dissolved solids and biological oxygen demand. So total dissolved solids would be like things like road salts and so on. So what we do is we take a beaker, a 250 milliliter beaker such as the one here, and we mass it, and then we pour a couple of 100 mils of water, of the pond water, the creek water, through a filter paper, and we put that volume of water into that empty beaker that we already weighed, and then we evaporate all the water out. And basically we remove all the liquid, and whatever mass the beaker gained, and we'll mass it again empty, but after the water evaporated through there, whatever mass that beaker gained is attributed to dissolved solids. If it doesn't take on any mass, then we know that there's not enough in there to be worried about. So. And then the last one is just biological oxygen demand, and all we do on that is we take a small vial and we wrap it in tin foil, and we measure the dissolved oxygen before and after, and that tells us if there's any microorganisms that are using up oxygen. So that's it. So tune in tomorrow when we look at some of these results.